Friday. And then when you come back from spring break, we will review on Tuesday and test on Thursday. And then we'll just have our very last chapter. We're done. Okay, so here we go. So let's talk about 3.4. So remember, let's think back to 3.3. What was the point of 3.3? The point of 3.3 was we had a big, long polynomial that stunk, right? That we couldn't factor. We couldn't put it in the quadratic formula. We couldn't solve it. So we would find a possible answer that was given to us in 3.3, a 0. We would use synthetic division, show that it had no remainder, and that synthetic division bumped down the degree one time, right, to something manageable. Then we could factor it or put it in quadratic formula and find the other zeros. So that was the point of 3.3. Okay, 3.4 takes it one more step. So this is if college algebra is like a mountain that you're climbing and the hardest part is the peak and then you come back down, today is the peak. You're at the tippy top of Mount Mass, okay? And you're up at the top, this is it, and then after today it gets easier. So here's the thing, remember root, zero, solution, x-intercept, they all mean the same thing, right? Okay, how are you gonna find one of these guys to test? How are you gonna find one of those if they don't give you one? Well, that's where the rational zero theorem comes into play. RZT for short, just because I'm lazy. Okay, so here's what it actually says. All right, I'm not even reading that because that's just, as Maricela said, and I'm quoting her, that's whack. Okay, so that's impossible. Here's what it actually wants you to do. It wants you to take factors of the constant term, that's the guy on the end with no letter, divided by factors of the leading coefficient, okay? Those are gonna give you possible choices that you could divide into your poly to see if you have a remainder, okay? Now, what we'll do is we will get our possible rational zeros, perform synthetic division till we find one without a remainder. That's a 0. Then we'll use the answer from this division to factor it, okay? If it's not able to do that or put in the quadratic formula, we'll do it again until it is. Now, this is the important part I want you to pay attention to right here. It's called the rational zero theorem. It means it's only going to give you rational zeros. All right, what in the world does that mean? That means no imaginary answers are going to show up. And in 3.4, you're going to have a lot of imaginary answers with an I in it. And there's not going to be a way for you to find those, okay? So, and until you work through the whole problem. So kind of keep that in mind. All right, remember that the degree gives you the number of solutions, right? If it's a third degree, you have 3 solutions, fourth degree, you have 4 solutions. Okay, also remember when you are dealing with an I, they come in conjugate pairs. So if you find an answer that looks like this, it means you automatically know another answer. It's this. So anytime an I is involved, they travel in pairs, okay? So his conjugate is also involved. Some answers occur twice. Remember, those are the touch and turns. They have a multiplicity of 2. They really can only be seen on a graphing calculator. So if you get stuck and you're like, I can't find another root, chances are it's one of your answers you've already had that's still in there, okay? The easiest way to solve these is with a graphing calculator. So I know you don't all have one, but hopefully you have the app that you could put it in, or you have the Desmos on the, your computer, your Chromebook, you could put it in. That will really, really help you, okay? All right, so let's start off here. These will be test questions. So we want to make sure we can do this. You will be asked to use the rational zero theorem on a test. Okay, so this wants us to use the RZT to list all possible rational zeros of this function. Okay, well, if you recall from the definition, that means we're going to have factors of the constant term, which in this case is 10, divided by factors of our leading coefficient, which in this case, there isn't one, so it's going to be 1. Okay, factors of 1. So it's kind of like you take it and you turn it like this. Students, oftentimes they make a mistake because they know they have to use the leading coefficient and they know they have to use the constant, but they forget who goes on top. They always forget that. The constant goes on top, the leading coefficient goes on the bottom. Okay, so here we go. Let's see. I need factors of 10. So if and I'm really adding a lot of steps in here because I just want to make sure you understand it, but what numbers multiply together to give us 10? 1 and 10, 2 and 5. I think that's it, right? Okay, what about factors of 1? 1 and 1, right? That's easy. We started off with an easy one. Okay, so our answer then, what we're going to do is put all of these on the top and all of these on the bottom. Now, we can't just use the positive versions. We're also going to need the negative versions. So what we do is we put plus or minus 1. Then I'm going to go to 2 next because it's in order. Plus or minus 2. Then plus or minus 5. And then plus or minus 10. I'm just putting commas between them. Those are all the factors of 10. And then in the bottom, all I have is 1 and 1. So I really just need to put it there once. Okay, this is not meant for you to cross these out. You can't cross them out on here and say, oh, look, I'm left with 2, 5, 10. Okay, don't do that. Here we go. We're going to do 1 divided by 1 is 1. Okay. 2 divided by 1 is 2. 5 divided by 1, 5. And 10 divided by 1 is 10. These would be the choices you would want to try in this polynomial. Now, this was a really easy one because our leading coefficient was 1. You can probably see where we're going with this. That was a really easy one. And already I have 1, 2, 3, 4, multiply it by 2 because you have the plus and minus version. 8 choices to use synthetic division on to find a 0. That's a lot of work, okay? So all we're doing now is finding possible zeros to try. So we get to stop. Okay, let's try the next one. All right, here we go. My constant is a 10. So again, I get to use factors of 10 in the top. But now my leading coefficient is a 2. So my denominator is going to be factors of 2. Okay, well, I already know factors of 10. And my factors of 2 are just 1 and 2. So here we go. All right, I'm going to put all the factors of 10 in the top and all the factors of 2 in the bottom. Okay, now I need to clean it up. We haven't had to clean anything up really yet because our other one was 1. So here we go. Let's make sure we can do this. We're going to start 1 divided by 1. Oh, I'm sorry, I don't need this fraction anymore. Sorry, guys. I don't know why I did that. All right, so plus or minus 1, okay? Then I'm going to take 1 divided by 2. That's plus or minus 1/2. Okay, I'm done with this one. Then I'm going to take 2 divided by 1. That's plus or minus 2. 2 divided by 2. Well, that's 1, and I already have it, so I don't have to list it again. So now I'm done with that one. Okay, 5 divided by 1 is 5. 5 divided by 2 is 5/2. Now I'm done with him. Okay, then I have 10 divided by 1. And then 10 divided by 2. Well, that's 5, and I already have that one. So now I'm done. So these are my possible rational zeros that I would want to divide into my poly and check and see which ones work. So does that make sense how we did that? We put factors in the top of the constant, factors of the leading coefficient in the bottom, And then we just took our time dividing them by each denominator. And then we had them. Okay. Sound like a plan? All right. So let's put this to work. Okay. It's a whole page. You start getting whole pages. Okay. We ready for me to flip? Is that okay? All right. Whole page. Here we go. All right. So here we have a poly. He has an exponent of 3. So how many zeros am I going to have when it's all said and done? 3, right? Because that's the degree. Okay, so here are your steps. You're going to list all rational zeros according to this rational zero theorem. Then you're going to start testing them using synthetic division to find one without a 0. Then use that 0 you found to find all the other zeros. Okay, that's the goal of the whole rest of the section. That's it. And so all we do now is practice this. So here we go. Okay, we'll do letter A first. Okay, we need to find possible rational zeros. Okay, well, I noticed that I'm going to have factors of 63 in the top. And then I'm going to have factors of 5 in the bottom. That's going to be my possible rational zeros. Okay, let's figure out what these guys are. So for 63, I've got 1 and 63. Okay, then in my calculator, I would do 63 divided by 2. Well, that's a decimal. That's not 1. 63 divided by 3, though, gives me 21. So that's a fact. Those are factors. I could divide by 4, 5, 6. I'm still going to get a decimal. But when I divide it by 7, I get that one. And then they start to repeat. That's all that I have. Okay, factors of 5 is just 1 and 5. Usually if you're going to have a long list for one of them, they give you a short list for the other one. Okay, so here we go. We're going to put in the top all of these in order, plus and minus. So I'm going to have plus and minus 1, plus and minus 3, plus and minus 7, plus and minus 9, plus and minus 21, and plus and minus 63. There's my new numerator. Okay, my denominator, I'm just going to do 1 and 5. Okay, that's that one. All right, now, most importantly, now we want to clean it up. Okay, so here we go. Let's see if we can clean this guy up. So we're going to do 1 divided by 1. That's just 1. 1 divided by 5. 1/5. Now I'm done with that guy. Okay, 3 divided by 1. 3 divided by 5. Now I'm done with that guy. All right, 7 divided by 1 and 7 divided by 5. Done with 7. I'm going to have 9 divided by 1 and 9 divided by 5. Done with him. Okay, 21 divided by 1 and 21 divided by 5. Ooh, okay. 63 divided by 1 and 63 divided by 5. These then are my possible rational. You have to be able to get that far. Okay. All right. Everybody okay with how we got that far? Okay. I know it's a lot. Okay. That leads us to B. B says at least one of these is going to divide into this poly perfectly without a remainder and be a 0. So your next step is supposed to be now use synthetic division and pick a 0 to try. Okay. You're going to pick a 0 to try. If you have no remainder, then great, you found a 0. If you do, if remainder, choose another and try again. Okay. So I don't know about you. There are some people in this world, you may be one of them, that you just kind of live with a ray of sunshine on your little head and everything you do turns out great. And you may be able to look at this list and get a feeling about one of these and you try it and it's a 0 and then you can move on quickly. I, on the other hand, am the person that if there are 5 grocery lines open and they're all the same length, I will choose one and then the person in front of me will stay there for 4 hours while all the other lines, go through. Or if I'm at the bank, I will get in because I think I'm choosing the shortest line. And then what happens? Their car breaks down, right? And I'm there the rest of my life. So I am not one of those people that can magically just get a feeling and choose a 0 and it works out. I will test every single one of these, the positive versions and the negative versions, and the very last one I try will be right. So I don't know about you, but nobody has that kind of time. So this is what you're supposed to do. Does that make sense? You just have to try the positives. You have to try the negatives. So you actually 1, 2, 3, 4, 5, 6, 7, 8. Oops, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then another 12 to account for the negatives. That's 24 possible synthetic divisions to figure out who is a 0. And half of these are ugly fractions. So a better choice is if you have the graphing calculator app, or if you have Desmos on your Chromebook, what I suggest to you, okay, is, let me get to the point where both screens can see, okay, I would graph this original poly and find out, kind of cheat, find out like who crosses the x-axis and use him. So here's how you do that. Okay, I'm going to go to y1 equals. Can you guys see that okay? Trying to make it so both can see it. Is that too low? That's too low. Okay, let's see. How about, okay. Is that kind of, yeah, that's okay. Let's do that. All right, so I'm going to put in the original poly from up at the top. I'm just putting it right in here. Okay. There it is. And I'm going to graph it. Okay. All right. So guess what these 3 x-intercepts are? Your answers. Those are the answers to the whole dang thing. Okay. Now, to me, this looks like a nice little whole number. This one looks like a nice little whole number. This guy right here is going to be a fraction because I know he's hard to see, but he falls right between 2 tick marks. So he's going to be one of those fractions, and I can't really tell who that's going to be. So I'm going to pick one of these nice whole numbers to use. So if I choose this one, that looks like -1, -2. It looks like -3 would be a choice. It also looks like +1, +2, +3 would be a good choice. Does that make sense? It kind of narrowed down where we're going to start. So you can either choose -3 or +3. I'm going to choose -3, and I got it from the calculator. And sure enough, look, that was one of our choices right there. Okay, now I'm going to do synthetic division. So I'm going to come up here and I'm going to get my coefficients from the original poly. Okay, so I have 5, -7, -45, 63. Okay, bring down my 5. I have -15. Add together. I have, sorry, I didn't have this worked out on here. I thought I was going to, but I got the wrong one. Okay, so that gives me -22. -3 times -22 is 66. Add those, I get 21. -3 times 21 is -63. Sure enough, no remainder, this means it is in fact a 0. And remember, this is my goal. My goal is to find 3 zeros for this poly. So that means one of them is -3. Okay, so if I already knew that from my calculator, why did I test it? Because I needed the smaller poly. I needed to find the smaller poly. So now I have 5x squared minus 22x plus 21. I use synthetic division to reduce him down. Okay. Now you have two choices that you can do. At this point, he's a quadratic. I don't know if he factors or not. He's kind of ugly. I think he does into something nice, but you could always use quadratic formula to find the next 2 zeros. Okay. And when you do that, you're going to come up with 7/5 and 3. Those are going to be the 2 zeros you could find in your quadratic formula. Or if you don't want to use quadratic formula, if you remember in the calculator, I still had another nice 0. Remember that? I used -3, but I had this other nice one here for +3. I could do synthetic again with a +3. So I could do 3 on the shelf. Now I'm going to use this poly, this reduced poly. I'm not going to go back up to the original. Okay, I'm going to use this one. So I'm going to have 5, -22, and 21. Okay, I'm using this reduced poly that I got from synthetic already. Do not go back and use the original poly. Multiply. Okay, 15, -22, that's -7. Sure enough, it's also a 0. So I'm going to come up here and put 3 into my little area. Okay, so we started with a cube. We knocked it down to a square. Now this is just going to be an x. So now my answer, my poly, is 5x minus 7. I can set him equal to 0 and solve. And when I do, I add the 7 to the other side, divide by 5, and look what I come up with. That's my last one. And there's all 3 answers. Now, if you'd used quadratic formula, you would have come up with them also. This is just an alternative way. You didn't get that on yours? Did you make sure you plugged it in like I have here? Do you have 5x to the third minus, whoops, hold on, I did something weird. Minus 7x squared. Okay, minus 45x. And then plus 63. Okay, let me come look at it. I want to make sure you get it because this is definitely way easier to do than me. Okay. Oh, okay. So that ever happened? Okay. Is that +3 at the end? Hold on. Where are you looking?
It's what's after the 45 on the calculator?
Oh, plus 63. Plus 63. You're up here. It's up at the top. Plus 63. Okay. And then we got all our 3 answers. Does the process make sense a little bit to you guys? Do you kind of understand what we're doing? I know it's not great, but you kind of see where we're headed. Okay, let's try the next one then. All right, let's do this one. This one's going to be a little easier. And then, okay, let's see how far we get. All right, So here we go. Directions just say find all zeros for the polynomial. All right. So I'm supposed to have 3. Step 1 is going to be find your possible rational zeros, right? I'm going to find my possible rational zeros. So in the top, I'm going to have factors of 18. And in the bottom, I'm going to have factors of 1. Because remember, it's the constant and the leading coefficient. That's what we're dealing with. Okay, let's find factors of 18. He's got quite a few, believe it or not. He's 1 and 18. He's 2 and 9. And he's 3 and 6. And then if you try to divide him by 4 or 5, he doesn't work. There's 6 repeats. 7 and 8 don't work. 9, it starts to repeat after that. That's it. Okay, and we already said factors of 1. That's easy. It's 1 and 1. So here we go. We're going to put all the factors of 18 in the top. Okay. And then we're going to put the factors of 1 in the bottom, and it's just 1. Okay. All right, now we're going to clean it up. It's always easier to clean up when you have a factor of 1 in the bottom because you really don't have to do anything. So we have 1 divided by 1, 2 divided by 1, 3 divided by 1, and 6 divided by 1, 9 divided by 1, and 18 divided by 1. There you go. We found all our possible rational zeros. Easy enough. Okay. All right, everybody okay with that? Now, we have 1, 2, 3, 4, 5, 6. And then if we double that to account for the negatives, we've got 12 possible choices that you could throw in there and look at. Or we can go to our calculator, right, and see what we can come up with. So if I put the original poly in here, I'm going to have x cubed minus 2x squared minus 9x plus 18. And I graph him. I'm expecting 3. And sure enough, here they are. And they all look pretty nice to me. They all look right on point. It looks like, let's see, -3, a +2, and a +3. I don't think I have any fractions at all. And you can also go to your table and look at your table and see, okay, definitely it's 3, it's 2, and it's -3. And since you knew there were supposed to be 3 and you found your 3, you can actually just write them and be done with the whole thing because you already found them on your calculator. See how easy that is? So you don't even have to go on and do anything if you don't want to. If you do want to go on and just make sure they're right, then you can choose one of those, any one you want, and do synthetic division. Okay, so let's just make sure that we're right. Okay, I just picked one. All right, I bring down a 1. -3 times 1 is -3. Get a -5. Multiply, get 15. That's going to give me 6. And sure enough, -3 is going to be a 0. Now, more importantly, what I did is I reduced my poly to this. Okay, I reduced it to that. So if I want to check the other 2 and make sure that they're right, I just choose a different one. You can choose any of them that you want and throw it in using this reduced poly and see what happens. Okay, when I do that, sure enough, look what I did. That one's also an answer. Okay, more importantly, what I did is I reduced my poly. And then to find the last answer, I'm just going to set this equal to 0 and solve, and there it is. So I found -3, I verified it here. Then I used this reduced poly and verified 2. And then I used this reduced poly and solved it and got 3. Now you can do those in any order you want. You don't have to go from left to right. I just happened to do that. But they'll all kind of work out. All right, does that make sense? Okay, let me kind of show you, and you might be thinking now, like, well, that's not that big a deal. Why does Ms. Holcomb hate this section so much? Okay, let's learn why we hate the section. Let's turn the page, and then you may develop some rage for this section. Okay. All right, here we go. Now we have a fourth degree. Okay, so that means we're now looking for 4 answers, right? Okay, it's always a good idea to do possible rational zero theorem because usually they will ask for it. Possible rational zero theorem. Okay, so I'm just going to save us some time here instead of writing all that out. We know we're looking for factors of 65 in the top. Well, I'll go ahead and tell you there are 4. Okay, just kind of trying to save us some time because I want to be able to get to the next one after this. And then in the bottom is going to be factors of 1. Okay, so just throw them on there. All right, easy enough. These are going to divide by 1 and give us these as our possible zeros. Okay, now remember, we are expecting 4 because that's the degree. Okay, so here we go. I'm going to throw it in my calculator so I know where to start so that I kind of have a starting point. So I'm going to put in x to the 4th plus 62x squared plus 128x plus 65. And I'm going to graph. I should see 4. All right. I don't see 4. I see 1. If I go to my table, okay, sure enough, -1 seems to be the only 0 that I see. Why can't I find 4 when I'm supposed to have 4? Okay, let's go back to the graph and talk about this. Up until this point, every time it went through the x-axis, what did it do? It crossed through, which meant it had an odd multiplicity. It was in there 1 time. This is a touch and turn, meaning it has an even multiplicity. This -1 is a 0, but it's in there twice. It's a factor twice. That's what multiplicity means. Whatever the multiplicity is, that's how many times you can divide that factor out of your poly. So this one has an even multiplicity. -1 is in there 2 times. Okay, Ms. Holcomb, so that accounts for 2. What about the missing 2? If you don't see them on here, it means they're imaginary. And the only way to get imaginary answers is the quadratic formula. Well, this starts with a 4th degree. I can't use quadratic formula unless I have a 2nd degree. So the only way to break a 4th down to a 2nd is to do synthetic division twice. 1 time would bring it to a 3rd degree. A 2nd time would bring it to a 2nd degree. Then I could use quadratic formula, and then I could get my imaginary answers. Okay, so what I'm going to do is use -1, and because it's a touch and turn, I'm going to pull it out twice. I'm going to do synthetic division with it twice. Okay, so I'm going to do not just a negative, I got to make a 1. Okay, -1. Okay. And then I'm going to put now be careful here because look what else we have going on. We're missing a term. So I almost messed up. Okay, I got to put a 0 in for an x to the cube term because I have to hold his place. This guy has like just a lot of problems, right? Okay, here we go. All right, so bring that down. This is a -1. Add it. Okay, that's a +1. This is 63. -63, add, I get 65. Sure enough, Okay, awesome. So -1, okay, is one of my answers, okay? But I never would have known that's in there twice if I hadn't seen the touch and turn on the graph. So now what I'm going to have to do is fill in my new poly. My reduced poly looks like this. I still can't use quadratic formula on him because I have to have a degree of 2. So now I'm going to go in and I'm going to pull out another -1. Okay, I'm no longer missing terms though. Now I'm all set. So I'm able to just put him right in. Okay, so again, why am I doing it twice? Because the graph showed me a touch and turn. And if it shows me a touch and turn, I have to do it more than once. Okay, so this is going to be -2. This is a 2, this is 65. And sure enough, look at that. It was in there twice. I know that because I got a remainder of 0. Now I'm going to go ahead and put it up in here twice. My math lab really doesn't like that. It likes for you to just put it once, even though we know it was in there twice. Okay. All right. So most importantly, what I did is I reduced my poly to a situation that's a quadratic. Now I can use my quadratic formula because remember, I only saw a -1 on my graph. That was it. So my other 2 answers must be imaginary. And the only way to get them is quadratic formula. Okay, so let's see. A is 1, B is -2, C is 65. Okay, I can't factor that because again, answers are imaginary. Okay, so I'm going to have opposite of B plus or minus B squared minus 4 times A times C all over 2A. Okay, I know I'm going kind of fast just because I wanted to get to that next one. Okay, that's going to give me inside here under my root is going to give me a -256. Okay. Now I can't do my magic triangle because I'm not allowed to go under that radical. So what I'm going to have to do is handle this negative. What does it mean if I have a negative underneath a square root? I. Okay. Then if you take the square root of 256 in your calculator, you're going to find out it's actually perfect. It's 16. Okay. Now can I use the magic triangle? Yeah. And I get 1 plus or minus 8i. Those are my other 2 imaginary answers. So my situation is going to look like, my answers are going to look like this. -1, which you only have to list once. And then you can do it this way if you want to. If you don't like listing them like this, you can do 1 plus 8i, 1 minus 8i. You can separate them if you want to. And those are your answers. So you can't always take the easy way out with a calculator. It's a great tool and it helps you. Sometimes these are just a pain in the butt, right? That's a lot of work. Okay. So do we understand the process behind it, even if it's kind of stinky? Maybe I'm going to text all of you that question. That's the only way I'll get you to respond. You're all looking at your phones. Okay. Miss Holcomb appears on SnapMap or something. Okay. All right. Let's try the next one. Let's go the other direction. Okay. What if instead of giving you a poly and asking you for the answers, what if I give you the answers and I want the poly? Okay, well, that seems a lot easier, right? It kind of is. It's just a lot of algebra. Okay, this means there are 3 zeros or 3rd degree. Okay, so that's what we would expect to have. Here I have 2 of the zeros. And then I have this weird piece of information down at the bottom, which we'll get to in just a second. Okay, so if I have 3 zeros, I'm going to expect that x is going to equal 3 things. Everybody agree with that? right, first thing it's going to equal is 3. Okay. Next thing it's going to equal is 5i. What in the world is my third one going to be? Any ideas? Remember that little piece of information I threw in there at the very beginning when I said that imaginary numbers travel in pairs. They always travel with their conjugate. So if I have 5i as a 0, guess who my other 0 is? Negative 5i. They don't tell you that, but by giving you 5i, that's what that means. Okay, now I don't just want answers, I want packets. I need packets. So how am I going to put x equals 3 into a packet? I would subtract it over and do x minus 3, right? Remember that? If you have this packet, that's what that answer means. Everybody kind of remember that rule? You just got to go the other direction. So what's my packet for this guy going to look like? X minus 5i. What about this packet? X plus 5i. So to get my poly, I need to multiply all 3 of those together. All right, I strongly urge you to do the imaginaries first. I know it stinks and you guys love to put off hard stuff, but by doing these first, you're going to get rid of the i's and it's going to make your life a lot easier. So let's forget this guy for now. And let's do these 2 and multiply them. Okay, that's going to give me x squared plus 5ix, that's weird, minus 5ix. Those are going to cancel, so even though they're weird, they're going to go away. Minus 25i squared. Okay, what is I squared? It's -1, right? Okay, so I'm going to have x squared. What can I change minus 25i squared to? Plus 25. Remember, I can get rid of the I squared and change the sign. So that's convenient. That's my new little packet. All right, don't forget about this next, this x minus 3. I'm going to take him. You can put him in the front or the back. He doesn't matter. But you're going to need to FOIL him now. You're going to need to multiply him through. Okay, so we're going to have x cubed minus 3x squared plus 25x minus 75. Okay. Everybody okay with what I did? I did the imaginary packets first, cleaned them up, multiplied that answer by the x minus 3 packet, cleaned it up. Now I'm not done. That's not my answer. How do I know that's not my answer? We never used this weird little piece of information. This is to make sure there wasn't a GCF that was pulled out first. So what this is saying is you'll have the correct coefficients. If you do, hey, y'all quit making so much noise now. Give me a couple minutes. Okay, x minus 1, when I push that through, it's supposed to equal -208. So let's try that. I'm going to put through a -1. Okay. And see what I get. All right, I know we're running out of time, so I'll go ahead and tell you I get a -104. Well, that's not cool. What am I supposed to get? -208. So what you're going to do is take what you're supposed to get divided by what you actually get, and you'll come up with a number. Okay? Then you're going to take this and you're going to multiply it through this poly that you found. And when you do that, what you come up with in the end is finally your answer. And you can check it. You can push through -1 and you will come out with -208 just to check it and make sure. Okay. All right. That is it. You little zipper fiends. Thanks for hanging around. I'll see you Thursday. Yeah.
Will you be sending me?
Yes.
Because I was like,